understand about higher derivatives. Now, when we have the sine the y over the x, and this is called the first derivative. First derivative. And the sine the y over the x is telling us that we are differentiating the function y with respect to x, and it's called the first derivative. Then again, if you have the function, if you have the symbol d squared y over the x squared, this is called the second derivative. Second derivative. And this second derivative is obtained by differentiating the first derivative. That is to say that the square y all over the x square is also the same thing as d all over the x all into the y over what? The x. So when you're interpreting this, it means you have d d over the x of dy over the x simply means you are differentiating the first derivative with respect to what? X. Now if you go further again, you have another derivative such as d cubed y all over the x what? Cube. And this same thing as you differentiating the second derivative, that is you have d over the x into d square y all over the x what? Square. So this is, in as much you keep on increasing, and we say it's a process of higher derivatives. So the derivative you obtain by differentiating the first derivative and so on and so forth are called the higher derivatives. So we'll be looking at some short examples in order to exemplify the meaning of higher derivative. All right, thank you. The second one will be the second place again. We'll be looking at the examples involved in solving higher derivative. Now, the first example says find the square y all over the x square for the following. Number one, we have y equal to x cubed plus x squared minus x minus 5, and then number two, you have y equal to x cos x. Now let's see how we can solve this particular problem. Solution. And I'm solving this problem given we have y equal to x cubed plus x squared minus x minus 5. Please, I want to correct this impression because I've come to understand that most of the time students don't understand the concept of algebra. So when they see problems like this, they might say that x squared, x cubed plus x squared would give them 5, rather x to the power of 5, which is not like that. These are like terms and they cannot be added together. Now let's see how we can do this particular problem, how we can solve it. Now solving this, you have to take the operator on both sides of the equation, meaning that the y over the x will be equal to, you have d over the x into x cubed plus, then you have d over the x into x whole square, then you have minus d over the x into x, and finally minus d over the x into what? 5. As we go further, you have the y over the x, and that will give us, by reason of differentiation, you know that if you differentiate y as x to the power of 3 with respect to x, you use the power to multiply the term and then subtract 1 from the power. So what I will say in essence is that this becomes 3 times x and then 3 minus 1. Then the next is plus, you have 2 times x and then 2 minus 1. Now if you come to the next one, you have minus 1 times x and then you have 1 minus 1. Thank you. Then you have the next minus. When you differentiate a constant, you have what? 0. So you have 0 this way, and then you have the y over the x equal to, this will give us 3x, and then you have 2, because 3 minus 1 will give us what? 2, plus you have this as what? 2x, and then 2 minus 1 will give us 1. Then you have this as minus x to the power of what? 0. And we'll come back again to say that the y over the x will give us 3x squared plus what? 2x, and then minus 1. The reason is because x raised to the power of 0 will give us what? 1. It is standard. And this becomes the first derivative. After you have gotten the first derivative, the next thing you have to do is how you can get the second derivative. How then do you get the second derivative? Is differentiating the first derivative with respect to x. So our differentiation still continues. Now let's get the second derivative, which is d square y over the x square. This will be equal to d over the x of the y all over what? The x. Thank you. Now we are going to differentiate. This simply means we are differentiating this first derivative with respect to what? X. So our second derivative, which is d square y all over the x square, will be equal to, come over to this part, you have this as 2 times 3x to the power of what? 2 minus 1. Then you come back, you have plus, so this is the power here is 1, so 1 times 2, you still have 2x, and then you have 1 minus 1. Then when you differentiate a constant, you have what? 0. And then, sorry, let's make use of this part of the board. Further, you have d square y all over dx square equal to, you multiply that, you have 6x raised to the power of what? 1. Then the next one you have is plus 2x raised to the power of what? 0. And the last one is, the last term is what? 0. So there will be no need putting the 0. We have d square y all over dx square equal to 6x and then plus 2. While because x to the power of 0 is equal to what? 1. And that makes the term this part to be 1. So 2 times 1 will give us what? 2. Hence, the second derivative, d square y over dx square is equal to 6x plus 2. This is how we solve to obtain higher derivative, such as d square y all over the x square.